I think everybody's back. We can get started here. The next module is going to cover math. And the way we handle the math in this program, it's not a standalone module where you just plow through that and that only until you're done with it. We sprinkle it in throughout the course. We're doing module 1, we incorporate a little math. Module 2, little math, and so forth. We find that's best, especially with the traditional students that we've had in this program historically. Math gets to be kind of overwhelming, and if you just give them smaller doses, they seem to handle it and retain it a lot better than if you just go nothing but fractions and then go into decimals and then conversions and then all the other things that go into that math module. But what I'm going to do is touch on some of the high points, some of the more challenging things that students encounter taking the math in this program. I think averaging, addition, subtraction, multiplication, and so forth, pretty much standard in math programs from school to school, but there are some things which seem to give students a little more trouble, and what we've got here on the slides are just some helpful hints on just how they might want to try to calculate these problems. But before we do, got a story, kind of falls in line with all our talk about the demand for advanced manufacturing and skilled workers and so forth. A story about a couple of brothers who just moved into the United States, and right away they wanted to get employment at a factory in the United States. And they went to an employer, and they went through all the paperwork and so forth. And they were called individually then for a one-on-one interviewing with the HR person. And the first brother, again, they came from the old country. The first brother, he sat down and the HR person said, well, why should we hire you? What kind of skill or trade would you bring if we would hire you? He said, well, in the old country, I sewed pantyhose together. Well, after that line of questioning, she wasn't too impressed with the answer, so she said, well, we'll call you later if we have a need. Well, the second brother comes in, and she gives him the same question. Well, what kind of skill or trade would you bring to our company if we would hire you? He said, well, in the old country, I was a diesel fitter. And without any further question, she said, hey, we'd like to have you come on board. Can you start tomorrow? And shook his hand and sent him over to complete some paperwork and all the other orientation things. Well, the first brother got wind of the news on his brother, and he comes storming in. He says, hey, why you let my brother in your company but not me? And she says, well, he's a skilled tradesman. He's a diesel fitter. She says, oh, yeah, I'll sew pantyhose, hand them to my brother, and he yells, diesel fitter.
That worked.
Yeah. The groans. Like I said, on these math problems, these are some of the more challenging problems, the sets of problems that we typically encounter. And what we got is just some step-by-step ways, and maybe you can walk a student through these problems. First off, there is a hard copy and also an electronic copy that they can use this as a reference, to get straight what the 10th place, the 100th place, the 1000th place to the right of the decimal point is. That gives students a lot of problems in case, if you tell them to round something to the nearest 100th place, they seem to think it's the 3rd place to the right because it's 100th place, 3 places to the left of the decimal point. Therefore, it just goes to stand that it's the 3rd place to the right of the decimal point. Well, no, it's not, because there isn't a 1th place to the right of the decimal point. You go right from 10th to 100ths and so forth. So something for future reference. They can have this chart so they can refresh their memory on, we're asking something from whatever place, they can look to that. But as far as converting something from decimals to percentages, it's very simple, but you just need to remind them, if you want to convert a decimal to a percentage, all you need to do is move that decimal point 2 places to the right. So if you start out with a number such as the one that you see here, 254 thousandths, all you need to do is move that decimal point 2 places to the right, add the percentage mark, and you got 25.4%. And then percentages to decimals is just reverse. Just move it 2 places to the left. So if you start out with a number that's 95.389%, it converted to a decimal number, it's 0.95389. Or take another example. If you have a number that's a single digit as a percentage, 8.235%, you always got to remind the student, you got to add that 0 because you're moving it 2 places to the left. So you got to add that 0 to the left of the 8 and make it 0.08235. And again, if you give them a visual that reinforces that rule of converting to a decimal, it's good. Still, you'd think that would be something that would be easy to retain, but it's been my experience. It's a mental block with a lot of people. Not everybody, but to a lot of people, it's a mental block. If you're starting out with fractions and you're converting that to decimals, a little trick that I had learned, some people might understand, okay, how do I convert that to a decimal? Some people understand, okay, you divide the numbers in that fraction. It's 2 divided by 4, but in the division equation, where does the 2 go? Where does the 4 go? Something an instructor had shown me, and it works with a lot of the students. They remember this. He just says, okay, if you're encountering a problem like this, where you're asked to convert a fraction to a decimal, remember trouble, TRBL, top right, bottom left. So you got 2 over 4, and then continue on dividing the problem. But sometimes you just need to give them little tricks like that to help them retain the rules in a math problem. So 2 over 4, you got the top number on the right, the bottom number on the left, and then you just calculate it accordingly. And this is how it should work out. 2 divided by 4, you come up with 0.5 or 1/2. And then decimals to fractions, again, another chart to remind them that the first number is tenths, hundredths, thousandths, 10,000ths, and so forth. And then, again, converting decimals to fractions. If you're reading it properly, this is what it should be. If you're converting it to a fraction, it's 35,578 over 100,000. Typically in this program, you won't come across fractions that big. A lot of times we deal with hundredths to thousandths, but again, give them an illustration of just how to remember converting decimals to fractions. And again, the rule, convert a decimal to a percentage, you move the decimal point 2 places to the right. And again, here's your division problem that we had a couple of slides ago, and that's how it calculates out. And remember trouble, top right, bottom left. And okay, your answer only has 1 digit, and again, if you're converting the decimal to the percentage, you got to add that 0 just like you did on the other problem when you started out with a 8 point whatever percent, and you converted that to a decimal. You had to add that 0 to the left of the 8. And you had to do this now. You had to add that 0 to the right, so that 0.5 is 50%. So you need to add the 0. And then once you get that, you just move the 2 digits to the right, and you got 50%. Moving the decimal places to the right for decimals to percentages. Okay, just doing some review here. Okay, now we do have some story problems in both the midterm and the final, and this kind of challenges their math skills a little bit. We're asking them to calculate time in terms of hours, minutes, and seconds, but if you give them these basic rules, you can walk right through it, and students have done a pretty good job retaining it for the most part. Let's just look at this story problem. You got a metal coater. It can cover 40.6 square feet per hour, and if you've got a 256 square foot product, how much time would it take for that coating machine to complete its task? And again, you need to give it in hours, minutes, and seconds. So what you're doing is you're dividing the area in which it's coating by the rate. That's 40.6, and then of course you got to eliminate the decimal from the dividend. So you're dividing 406 into 2560, and once you get that set up, okay, this is the answer that you come up with when you divide that, and your answer is 6.305. Anybody know what that is? 6.305 what? It's hours, okay? That's correct, 6.305 hours. So what we do is we take that 6.305, and usually we tell them to round their answers to the hundredths. Okay, that's 6.31 hours. So you've got 6 hours, and then how many minutes? You take the numbers to the right of the decimal point, multiply it by 60 minutes, and you come up with 18.6 minutes, and then you repeat the process to calculate your seconds. 0.6 times 60 seconds equals 36 seconds, and your answer will be 6 hours, 18 minutes, and 36 seconds. Just one of these little more tough math problems that we've incorporated in here, as part of the curriculum. And then we have another math module where there's another set. It's actual, some machining type of math problems. And, okay, let's say you're a machinist and you're lathing an aluminum rod. It starts with a diameter of 11/16 inches, and you're turning it, and your finished diameter is 0.495 inches. And you're asked to give the answer in a decimal form, round it to the 10,000ths. And then in addition to calculating, what the answer is on the first part, you got to calculate the percentage of reduction. Again, it's a little tougher math than what they would typically encounter in this program, but we put them in there for, just to challenge their skills, see if they can retain this. So here's how we started. First, convert the fraction to a decimal, and again, using our friend Trouble, top right, bottom left. So you got 11 divided by 16. You come up with 0.6875 when you work it out. Okay, your beginning diameter is 0.685, and then you subtract the ending diameter, 0.495, and you come up with the first answer, 0.195. That is the amount of reduction that you had when you turned that aluminum rod. Now the next part, that's the part that seems to trip them, but again, we inserted this into the program to give them a little bit of a challenge. What is the percentage of reduction? So to calculate that, what you do is you divide the amount of reduction, which is the 0.1925, by the beginning diameter, which was 0.6875. And then you do your basic division principles. You move your decimal point 4 places to the right, so you eliminate the partial number, and then you calculate it out. And when you work it out, you come up with an answer 0.28. Now that's in decimal form. We're asking for the percentage of reduction. So again, we go back to our mathematical formula to convert a decimal to a percentage. Just move it 2 places to the right. And your correct answer should be 28%. And again, this walks them through there. You can print these in a PowerPoint. You can print them up as hard copy to help them study. But it's just one of those little more challenging math problems. And I think we gear it primarily for people who do have aspirations of getting into more advanced manufacturing jobs, or maybe considering something beyond this basic pathway class. And if you do, you're going to be looking at some math that's even more advanced than this. But get their appetite whet to give them an understanding of the level of math that they could be looking at, whether it be through the job or for additional education. And then here's another, I think this is pretty similar to the last one that we had in the last slide, but just run through the program on hours, minutes, and seconds. I think that was just a repeat of what we had before.
Doug, do you allow them to use a calculator on the final test?
We typically don't.
Okay.
Yeah, and you bring up an interesting point. We're offering this class right now at the Worth Center, which, if you're familiar with that, it's a nonviolent offender facility on the north side of Lima. Basically, people who were arrested for drug, alcohol violations and things like that. And we're teaching this class in their program right now, and there's a couple of them. They said, we've never had to do long division before. We've always just been able to use a calculator to figure our problems. And I tell you, we might as well put a trigonometry problem in front of them. They were just problems that were probably simpler than this. But yeah, just try to encourage, development of some skills to calculate. Granted, in this day and age, your access to computers are, you carry it around on your phone, you've got them everywhere you go, but we're just being a little old-fashioned, I guess. Just encourage them to learn basic math skills on pencil and paper. Calculators will always be there, but I think there's something to be said if you can calculate things on pencil and paper too. Any questions on what we covered in the PowerPoint? What I want to do is just kind of walk through Module 4. You've got a lot of tools here. There's practice math exercises. There's assignments that you can send home with the students and so forth. Just a number of things that you can do. And again, more material than what you'll probably need. But if you see a certain type of math problem that you think they would need a special amount of work on, there's something in there for it, and you can make copies off of this and give it to them for assignment. There's answer sheets also. You've got answer pages that go along with the math problems. So you've got the ability to be able to check on them to see if they understand the math problems or not. I'm looking here. This is the complete and unabridged version. I normally would tell you to turn to page 17, but we also incorporate measurement in our math module. We give them some hands-on exercises in dial calipers and in rulers, and that's probably one of the more practical things that we are teaching. I was surprised to learn actually from one of our students who had completed our basic pathway class. She got a job with a pet food company, ProPet, over in St. Mary's, and she was telling us that they use calipers to measure the dog food nuggets. Now, I don't think their tolerances are that strict, but I think they do have some level of quality control where they can't be too small or they can't be too large. But long story short, this was her first exposure to using dial calipers, and she was saying, well, I'm glad I took the class because at least I had some understanding of what these were and how to use them. And then she got more comfortable with it as she got the experience with it. But surprising to hear that they use it for that. But even in a lot of cases in some entry jobs, they might be producing products and they're asked to sample every so often just to make sure that the product is within the tolerances, whatever they may be, thousandths of an inch, 10,000ths of an inch. And we do give them some lessons in dial calipers. And again, it kind of goes with the paper and pencil versus the calculator. Some of the people who have had some experience in calipers, they say, well, we use digital. We've never used a dial. Well, we're going to teach you to read a dial caliper. If you can master that, then the dial caliper or the digital calipers will come pretty easy for you. Kind of the same principle as far as machinist versus CNC operator. The manufacturers in West Central Ohio that we have a training program for, they say, well, we have a shortage of CNC machinists, but we just don't want people to just jump right in at CNC without actually having experience in turning or milling. We want them to have some hands-on experience doing those things before they go into a CNC machinist. They want to understand what the feel and what the sounds of being a machinist are, and then they would have a better understanding, better relationship on being able to operate a CNC machine. So, yeah, sometimes you just need to get a little more basic to have an understanding of the more advanced things in a program. The dial calipers, has anybody ever used them before? Anybody ever used a caliper or a dial caliper? We're actually going to do a little drill on this right now. These are pretty simple. I was asked to get a shopping list of the materials that you'd have to buy, and unfortunately, I don't know if you heard the story, we had a virus in our computer, and I didn't get a chance to put that list down, but I will compile that and email that out. But these are pretty good for what we need them for. They're 6-inch dial calipers. We can buy them at Harbor Freight for about $15. They're relatively inexpensive. Steel rulers, the kind that we get, Ben Frail, who's in the engineering department, he can order them for us, and they're about $2 to $3 a piece. And what we prefer on them is that they've got scales on both sides. They've got 64th, 32nds, 16th, and 8ths. And, again, $2-3 per steel ruler. But what we're doing is just give the students a little hands-on exercise in using dial calipers. And what we're going to do, I think we've got enough for everybody here. And I've got gauges, and these gauges are set to the nearest thousandths of an inch, and I'll trust their judgment on how much they measure. But what we're going to do is pass out a few of these gauges, have you write down your answer to see if you understand, how to read them. But in general, a dial caliper, pretty versatile tool. You can measure 3 different ways. You've got this, which can measure length. You put your product between the beveled edges here, and it'll give you a measurement to the thousandths of an inch. If you're looking at measuring inside diameter or something, as you see as you adjust your thumb dial, this widens and you can measure inside diameter or something. Or if you want to measure depth, again, as you're adjusting your thumb dial, this thing adjusts up and down and you can measure depth. And again, readings can be to the thousandths of an inch, up to 6 inches. And that's the size that we have. That's been the acceptable size that we've always needed. You can get things which are a little more precise, a little bigger. We've had students who had some experience and they said, yeah, I've got a dial caliper and it cost me about $300. $15 at Harbor Freight. These are pretty nice and sturdy. If you're in a position where you want to measure something consistently, let's say they have to be an inch, you set your caliper to exactly 1 inch and you lock it. You've got a screw here which holds it in place so that there's no wavering. Or if you have to, if your dial doesn't read at a true 0 when you have it completely closed, you may need to, it's not calibrating it, but you might need to adjust the dial maybe a thousandths of an inch or so. And if you have to do that, then this dial here will loosen the dial and lock it into place. So yeah, that's a pretty handy little tool for teaching. And it's one of those things, if you've never seen it before and you at least get a basic understanding of how to use it, students really light up. They seem to enjoy it. And once you give them an understanding of how you read these numbers and how precise you can measure, and then you never know. You might have a job where you actually have to use this, and this gives you an edge over your competitors if you're applying for these jobs. So what we're going to do, I think I've got enough calipers here. We're going to give everybody a set along with a worksheet, and I'm going to pass out gauges. And what we're going to do is measure those gauges. Write down your answers. You just take and pass them down.
Is most of the manufacturing all still English units, no metric?
It's mixture. The Japanese, I see more metric. I still see a lot of English though. We just haven't converted as fast as what I think they were saying we would 30 years ago. I thought we would have been totally converted by now.
You said individually.
Yeah, everybody should have a dial caliper. I think I have 15 in here. If I don't, does everybody have a set? We're short? I thought I brought 15. Okay, here's another set. Who needs one?
There you go.
Or you can share one.
I share.
Yeah.
Yeah, we share.
Okay.
They need one.
Well, I've got one here. Sybil, did you need it? We're going to pass around worksheets with your answers. Yeah.
Well, what you have happening, food texture, we just bought a food texture analyzer, and it's the difference between?
I've actually got 10 of these gauges marked. We've got 15 people here. What I want you to do, each of these gauges has a number written on it. You write down your answer on the number that matches the number written on the gauge. And if you see a T, that means you measure the thickness of the gauge. And there's 9 of them that you measure the thickness. Otherwise, there's the one that you measure the width of the gauge. So let's just distribute these the best we can. Take one, pass them around. Okay, what did we get for gauge number 1? What did you have for an answer?
Come on.
I had 0.90. Yeah, 0.9.
Should be the correct answer is 0.900, and we'd accept anything from 0.899 to 0.901. Okay. Gauge number 2. I heard 0.105.
I had 106.
Yeah, the exact measurement is 0.106. We accept 0.105, 0.107. Number 3. What did we get for number 3? 0.101.
Yep.
Everybody agree? That is the exact answer, and within the tolerances, it'd be 0.100 to 0.102. Okay, number 4. What was that?
150,000.
Yeah, 150 thousandths or 1500ths. Everybody agree with that? Okay. Number 5 or number 5. $130. Everybody agree with that?
Say it again, sir.
130 thousandths or 1300ths, 0.130. Everybody agree with that? Okay. Number 6. 0.103. That should be your answer. Anybody have different? We accept 0.102 to 0.104. Number 7. 200 thousandths. Everybody agree with that? Okay. Number 8. 180. 180 is the exact measure. 179 would be acceptable given the tolerances. And number 9. 108. That's correct. Everybody get that? Anybody have something different? We'd accept 107 to 109. And number 10. 105. Agreeable? Easy to grasp, was it? Was it imposing at first? Just giving some students a little exposure to some precision measurement, something we were talking about during the lunch break. Minster machine, now Nidec Minster, they make these massive presses. Some of these things weigh 15, 20 tons. Some of those things, they have tolerances in the construction of those machines to the 10,000ths of an inch. So, if you're off 10,000ths of an inch in where you drill your hole or where you mount something, you got yourself a big expensive piece of scrap iron. Something else we were also talking about, before Aubrey had just left, he was talking about the future of the beverage industry, and that could have an impact on Minster machine. He was saying that aluminum and plastic containers are becoming obsolete ways of marketing beverages, and this is, what's going to replace them? Basically pouches like you see with the children's fruit drinks. But Minster machine, right away I thought of them. they make presses for the aluminum beverage container, and their claim to fame was like 95% of the aluminum beverage containers consumed in the United States are made by presses made in Minster machine. I mean, that kind of boggles the mind when you think of all the soft drinks, the beer, all the containers of alcoholic, non-alcoholic beverages. 95% of those containers are made by presses produced in Minster, Ohio. But they might have to find another market if that comes to reality, what Aubrey was just talking about. Next part of our measurement exercises, we don't have as many rulers. We've got them loaned out to about 2 or 3 different places, so we'd have to share for 2 or 3 people. You've got a series of 10 lines. We're not going to do the bottom part where you add up the total length of all the lines and that sort of thing. Just give the measurement of the 10 lines. And you know, if the tolerances is 1/16 of an inch, use the scale on the ruler that's measuring to the 1/16 of an inch. You look at the ruler, you look on one side, the scale is 64th and 32nds, and then you flip it, it's 1/16 and 1/8 of an inch. Just take a few minutes to measure the lengths of the 10 lines that you have here. Don't worry about the supplemental exercises at the bottom, but just see if you're able to measure accurately within the tolerances we've given. To tell you my age, my eyes going like they are. Some of that print on those rulers is pretty fine. You got to really look at it to make sure you've got it right where it needs to be. This exercise should go a little faster. You're not waiting on a gauge.
Somebody
everybody got their measurements done? We'll just run quickly through these. What did we get for the first line?
1, 23, 30 seconds.
Yeah, 1 and 23, 30 seconds is the precise measurement. Number 2? 19, okay. Number 3? 1 and 1/8, correct. Number 4?
360.
Number 5?
17, 30 seconds.
Okay. Number 6?
64, 1.
63, 64.
What was it?
1 inch. You were within the tolerances.
I thought it was just.
I thought 64 is an inch.
And I'm really,
Yeah. We can accept 64, 64. Number 7.
11, 30 seconds.
That's good. Yeah. Number 8.
8.
Okay. Number 9. Number 10.
133.
Okay. Number 9 was 39/64. The last one was 1 and 13 or 30 seconds. Yeah. Yeah, and we've used rulers a lot more than we use calipers. It goes without saying. Hopefully the students are the same way. We just leave them on the table and collect them at the end. But yeah, you know, when we look at job descriptions on the postings that we send out to students in our pathway program, and then we post out on the bulletin board, quite a few of them, they said they need to understand at least basic math and measurement, and that would mean being able to read rulers, tape measures, maybe even calipers. There's a few of them that we've been hearing that they have used calipers, and so we try to incorporate that so that we get them a fighting chance of making it through the screening process, and then at least be familiar, and the learning curve isn't so steep when they do get hired with the job. They've had some exposure and an understanding of how to read them. And like I said, chances are, if we're having them reading dial calipers and they understand how to do that, they get the digital version of calipers, that'll come much, much easier. Something that we try to teach them and get them competitive for the job market.